Good afternoon, and thanks for the warm welcome. I know it gets quite difficult after a heavy lunch to sit in a session and look at the metrics and the performance aspects of it, but I'll keep it as interesting as possible. So I'll give one more minute to let the people settle down, and then we can start. Okay. Now the session title is using Selenium to visualize real user experience of performance and gathering some metrics around it so that it can be useful for your performance test analysts to look into what are the problematic components in your web page and actually get what the real user is perceiving your web page to be. Now this is something most of the Selenium guys are doing, but probably may not be aware that they are doing this, because I see a lot of questions on this particular topic on Stack Overflow and a couple of Selenium forums as well. What do I do? I'm a senior performance architect at Gallop Solutions. Most of my time I spend tuning IIS and JVM for better performance of those applications. I've around 10 plus years in performance engineering. I'm specifically interested in studying end user behavior with respect to the performance of the application as the performance degrades or improves, how those users are funneling into your application and how much time are they spending on your application based on your performance. I'm fascinated by data visualization because in performance testing you get a lot of data, sometimes gigabytes of data, and it's hard to fathom what the data tells until and unless you convert them into a visually pleasing or visually informative charts and graphs, etc. I'm a travel buff. You can contact me on a Twitter, on LinkedIn using those handles. Now the question, why should anyone use Selenium for performance testing? Because Selenium is obviously a functional automation tool, and rarely we talk about using functional automation tools as a part of performance testing. There are a couple of reasons behind it. The first and foremost is there's a huge gap in the current performance testing tool market. I have been working with LoadRunner, Silk Performer, Visual Studio, Performance Test, NeoLoad, to name a few, and JMeter as an open source tool. Most of these particular tools do not actually emulate your real browser when it comes to testing your web applications. What does that mean is they actually record and playback tools. They play back your request sequentially rather than opening up 6 concurrent connections like a normal browser does. A couple of tools have this capability. For example, LoadRunner does have this capability of emulating 6 parallel connections, thereby getting your performance numbers close to what your end users might see. But then there is a problem with the JavaScript engine, which is not supported out of the box for the LoadRunner or any performance testing tool. And there is a valid reason why these testing tool vendors are not doing that out of the box, because once you start plugging in the JavaScript engine into the virtual user technology, you'll be limited with the number of users that you're going to scale on load generators. So to keep the scalability to an optimal point, most of the tools do not actually provide you the JavaScript engine capability. And some tools address this problem by emulating real browsers, in this case a true client by LoadRunner. What it does is it brings up a Firefox or an Internet Explorer instance and then plays back your recorded script and tells you what the end user times are like. But then it comes at a cost. These particular true client protocols do not scale well when you want to run load tests with high number of users per instance. And on the modern web landscape, some part of the load that is previously processed on the server side is being moved to the client side because of the power, the computing processing power, the RAMs and etc. getting thicker and fatter on the client laptops. And with Ajax technologies and jQuery and a lot of processing happening on the client browser side, there is a significant amount of load happening on the browsers, as a result of which, if you want to test performance of a web application using a conventional load testing tool, you do not get a clear picture on what's happening with your load test. The case in the point is a lot of Ajax queries and complex JavaScript, DOM manipulations, CSS manipulations, etc. And they often miss the crucial JavaScript part. And because of the sequential processing of the lack of ability to emulate a JavaScript engine, the timings reported by load test tools are not actually the true representation of your end user perception. So 3 seconds of your SLA on your normal browser can be reported as 4 in one tool, 5 in another browser, and the confidence you want to have in your numbers goes down as you actually go and increase the load and see what's happening with your load test. There is this navigation timing API according to the W3C standards, and every browser supports this navigation timing API, and it gives you certain numbers between the time you initiate the request and the time you get the response and get it loaded on the web page. There are several stages here, and you can actually look into how you can tell what is the particular latency, whether your request is suffering from a network latency, or is it because of a browser's JavaScript engine and hardware of the client, or is it because of the other factors like DNS manipulations or DNS lookups or slowness due to redirects or component level problems happening. Now, not many load test tools out of the box provide a support for getting visibility into these numbers, and this is what we are trying to do by plugging in Selenium with JMeter and getting a perception on what might be the problematic areas in my web page. Is it because of the redirects, or is it because of the network, or is it because of the connections, etc., etc. Now, what we are trying to do here is we want to mix JMeter with browser mob proxy and Selenium using a bean sampler shell and then execute a test. What it does is the JMeter actually pushes the load onto the servers in terms of number of requests per second. For example, if you want to test your servers up to 200 requests per second or 300 requests per second, now that particular load is taken care by your JMeter load injectors, and then parallelly we want to run a bean shell with a Selenium WebDriver with a browser of your choice, be it Chrome, be it Firefox, be it Internet Explorer, and get the timings from the navigation timing API on what your end user response times really look like. And why we are doing this is because there are a lot of factors which can affect your performance of a web page. Now, if you talk about browser, generally when a browser encounters a JavaScript during your network transmission, it has to pause itself and it closes all other connections which are actually downloading the other resources until and unless it understands the JavaScript, compiles it, and then proceeds for other components of the web page. Similar is the case with the CSS selectors. Until and unless your browser understands your CSS or a JavaScript, it's not going to fire any more downloads. Now compare that with a load test tool which doesn't actually look into these particular aspects, and it treats every JavaScript or a CSS or a web page as a normal resource and tries to download and do not actually imitate those particular latencies that are on the client side. Another thing is serving too many JavaScript files on the browser and large DOM manipulations, slow execution of external requests, third-party calls, etc. And on the mobile part, you will have these unresponsive screens, frozen, slow user behavior, or your mobile being, now it depends a lot really on what your mobile processing power is, how many applications are running in the background, etc. So normal load testing tools do not actually give you an end user perception of performance, but then there are tools like Perfecto, etc., which do that. What we are trying to do here is to get an open source version of it and then see what best we can do with a minimal cost in our hands. On the programming side, there are obviously the Steve Sauter's 12 rules, which talk about minimizing the HTTP redirect, minimal client-side processing, etc., etc. Now, browsers work differently. Your Internet Explorer is different to Chrome, and it is different to Firefox, and different to Safari on Apple. And in this multi-browser universe, you can't actually take confidence from an API level testing using a JMeter or a load runner saying that, okay, if I find my response times to be 3 seconds or 3.5 seconds from a load test of 1,500 concurrent virtual users, I'm going to take confidence into those numbers. It's not going to happen because that 3.5 seconds will be a lot different depending on the browser and depending on the network latencies as well. Now, I have tried to get some figures on the JavaScript performance of different browsers, and surprisingly, Internet Explorer scores better over all the other browsers. Now, that's a revelation, but Edge browser on Windows 10 really performs better when you compare with the latest versions of Chrome and Firefox. So that's the scorecard of the browsers. And it becomes really important for you to concentrate on those particular numbers, because if you are operating by SLAs and with users growing more impatient, you don't want to lose even 1 second of performance on your website, taking confidence of an API level numbers. So what is the approach that we have taken is to actually capture a hair file out of the executions that are done by Selenium WebDriver and put our SLAs in place in the code itself. If the code is going to take more than 2 seconds or 3 seconds of time frame, get a hair file out of this particular browser activity and push that onto an online hair viewer to see what exactly it looks like, or what is the component that is taking most amount of time. Is it because of the connect time? Is it because of the DNS time? Or is it because of anything, any other things? Now the web page analysis, it provides a breakup of the entire components within the website. It includes JavaScript, CSS, images, etc. And for each component, you get basically five different numbers. What is the connect lookup? What is the time it is spent waiting? What is the time it's spent receiving? And if there are any blocking as well. Now, at the end of the test, what you will have is, you will have a page load time similar to onload times on the browsers, depending on the browser version that you use with the JMeter and the Selenium WebDriver. And you can generate hair file with the client-side statistics for all the transactions that missed your SLA. And that becomes an extremely helpful tool in cases where you do not have monitoring mechanism on, because I generally go and test the performance of the applications, and only 60% of my clients use any sort of monitoring tools like App Dynamics or a Dynatrace or a Nagios, etc. Now, when you have those hair files with you, with all the client-side statistics, looking into what each component is doing, why certain component is taking so much of time during a particular request, or during a particular time of the load, or during a particular time of the day, it becomes a lot easier to isolate the performance bottleneck and concentrate in your efforts on, rather than actually looking for things which are not really visible. Now, how does Selenium actually help us in this case is, now this is the process of a particular web request. Now that is the process of every component on your web page, be it a CSS, HTML, JavaScript, or an image. You prompt for a particular resource, and the page unload happens. If there are any redirects, it's going to take care of the redirect, and then if it can be served from the cache, it can be served from the cache, it picks up from the cache, does the DNS lookups for the remaining components, and waits for a TCP connection to be available. In case if it is an SSL, it needs to wait for an SSL handshake as well. And then the browser starts your request and waits for the response. That is the time to first byte. And once the response is done, or in the middle of the response itself, depending on how you code the web page, depending on what is your technology stack, your DOM manipulation starts and your page starts loading, the DOM interaction happens, and finally a load event ends. If it's a progressive download, the load event can end at different points of time, depending on the user triggers. During this process, you have Selenium. Selenium can actually tap into metrics like what is the navigation start of the web page in terms of timestamp. When did the unload event start? If there are any redirects, when did the redirect start? When did the redirect end? And if there are any fetches from caching that needs to be done, when did that particular fetch start? And if there is any unload event, you capture that number as well. And then DNS domain name lookup start, domain name lookup end. And then you wait for the connections to be available from the server. On an overwhelmed server, you can see this particular number increasing depending on the load and depending on the latencies of your requests on the server. What is the connection end time for that particular component? If there are any secure connections that are happening on the browser, if there are any HTTPS transactions that are happening on your browser, and what is the time taken for the secure connection to be established? When did your client start the request, start sending the request to the server? And when did the server start responding with a chunk of the message or the entire message? That again depends on whether you're doing a chunk transfer encoding or a whole response altogether at once. And when did the response end? When did the DOM loading start? When did the DOM become interactive? And when the DOM content load event started, DOM content load event end, and DOM complete, load start, and load event start, and load event end. Now these are pretty extensive counters that are available on a navigation timing API, which your Selenium WebDriver can actually, Selenium can actually tap into and provide you with valuable information. It again totally depends on you on what are the counters that you want to use. Most of the time, I end up using only load event end in order to get end user perception of performance. But if I see, based on my hair files, if I see a lot of latencies across components and a lot of latencies across web pages that are violating my SLAs, I would turn on certain counters of this depending on my experience, depending on the user's experience there, depending on the developer's experience there, and what we see on the browser network profile. You might want to see now what is the time that your web pages are spending on getting a connections, what is the time that your web pages are spending on getting a response from the request. The tool set that we are using here is JMeter. It's a complete open source tool. It supports your HTTP, HTTPS, ODBC, SOAP, etc., etc. And then Appium for driving a load on the mobile emulators. Selenium in order to get Firefox driver or a Chrome driver or an Internet Explorer driver. And then browser mode proxy to get the hair file content onto the database or onto your file system in order to see what exactly is happening when a particular transaction is getting slowed down. Now, the entire solution landscape is like this. You have a JMeter controller, which does all the load generation. The one on your left side is the virtual user load, which actually acts on an API level. All these are HTTP requests, which are sent sequentially, and you tune this in order to reach a certain transactions per second or a request per second on your web server, so that you load your web servers to the level you want. And parallelly, you use your bean shell samplers to drive Selenium WebDrivers in a Firefox or a Chrome mode and put your conditions in place. If your particular page download time is greater than 2 seconds or 3 seconds, you might want to catch the hair file and store it for your offline analysis, or you might want to tap into the numbers that is provided by navigation timing API and store them in a database or an XML file for offline analysis. It's advisable to put an SLA onto the web-based transactions, not to put, not try to capture everything that is being done there. That's just because it can cause a lot of disk problems, and you will be inducing a bottleneck at the test infrastructure level itself. So I put it as a 3 seconds depending on a lot of web applications. And if the SLAs are pretty aggressive, like 1 second or 1.5 seconds, we take a different route altogether, saying that only 10% of these particular samples be stored in a database or an XML file. I'll just go on to a demo that we have done for Gallop.net homepage. This is what it looks like. We have a JMeter script here. The Gallop website is a standard JMeter sampler, which has all the HTTP requests, which will be played in a sequential manner. And then when we have a Firefox WebDriver doing the same thing, it visits the Gallop.net web page, and if it is greater than 2 seconds, if my response time is greater than 2 seconds, what it does is it creates a hair file with that particular timestamp and the response time value for an offline analysis to see what exactly happened with my web page when it has taken 2 seconds or greater than 2 seconds. The same thing which we have repeated with Chrome. You open a Chrome WebDriver and it's completely the same code. And then you write these particular values. At this point, I'm writing to a CSV, or you can write it to an XML file, or you can write it to a database the way you want to get the offline analysis done. And you will see that the performance metrics shown by a JMeter varies greatly when compared to a Chrome and Firefox. And then you will understand why this particular approach becomes increasingly important in the current modern landscape. I'll just go ahead and start this test and then see what the numbers look like. This runs for two iterations. It runs for 2 virtual users on JMeter, 2 virtual users on Chrome, and 2 on Firefox. Okay, I'm going to the results table. Now the Gallop website, the label Gallop website, and the sample time in milliseconds is the time reported by JMeter, which is 1.4 seconds. And the sample time for Firefox is 24 seconds, but obviously that's the time spent by JMeter running your Chrome thread. And that's not exactly what your response time is, because if I go back to my Selenium WebDriver code, on my Firefox, I'm typing into an event called load event end. This is where I'm typing into the load event end and then subtracting the starting time and then logging it as what my response time is. That's not the same as 24 seconds what JMeter shows. Let's go to the CSV file where it logs the results. So 1 and 4, 1 and 1, 1 and 3, these are the response times that are shown by Chrome and Firefox respectively for different iterations that we have done over a period of time. Now take that particular analysis onto an Excel file or a graphic or RStudio or whatever you use to get that particular analysis done and put a graphing in place. What you end up with is this particular behavior clearly shows that what your JMeter consistently shows as 1.3 seconds or 1.4 seconds, that's the red line at the bottom of all the 3 lines, is actually very different from what your real users are saying in terms of a Chrome or a Firefox. The Chrome tends to be pretty consistent in terms of real user perception of performance of Gallop.net with only 1 spike going up to 5 seconds. But Firefox seems to be pretty inconsistent in the terms of performance of that particular web page. And get on to the next metric. What your tool tells you is your average time is less than 1 second, maximum time just over 1 second, 98th percentile just over 1 second. But the reality is you are ending up at 5 seconds on max with a Chrome browser and 3 seconds on a max on a Firefox browser, which is completely different from the regular toolset metrics. And look at the load variation and the response time variation according to the load. The JMeter always tells you a lesser number when compared to a real browser. That's because of JMeter's inability to actually emulate the JavaScript engine and emulate the latencies that are induced by CSS selectors and JavaScript files on the client side. But if you look into the green and the yellow lines, that the Firefox and the Chrome, that's the numbers you want to take confidence in. Now you might want to split this particular analysis into 2 parts. So one being your JMeter virtual users actually stressing out your servers, and then you look into the health of the your web application servers and database servers, and make sure that you're currently in green zone. The green zone is with a less than 60% CPU utilization and close to 65% memory utilization is a green zone. So the moment you start pumping this load onto your web servers, which is a sequential load from JMeter, that's where your server health numbers come from. And if you want to take a real user perception, which JMeter doesn't give you with confidence, the Selenium web drivers with Chrome and Firefox help you get those numbers, and put these two pieces together, you have a complete picture on what your website is doing on different browsers. You can include as many browsers as you want here, on a Safari or an Internet Explorer, whatever Selenium supports. And if we want to look into what happened with those particular 5 seconds, etc., what this particular solution does is every time an SLA is violated, it creates a directory and writes a hair file into the directory that you specify with, I have asked you to write with the response time value at the end of the hair file. So the one I have selected is for the 5 seconds that has taken on a Chrome browser. And once you have a hair file, you can go on to any hair viewer online. This is the one I use generally. It's open source, it's free to use. You can just go onto this website and select your hair file, drag and drop it onto this particular screen. And it tells you a lot of story that out of those 5 seconds, which is an anomalous response, because Chrome is consistently giving you a response within 1 second, but then you have an outlier of 5 seconds, and you want to know what happened with that particular instance where your page is taking 5 seconds. That's where you are seeing a particular CSS spending almost 3 seconds in getting a connection to the web server, which indicates a possible problem with the number of TCP connections available on the web server, which might not be the case, which might be the case as well, but it provides a data point for you to look into what exactly is the problem behind my web page that is behaving at, weirdly at 5 seconds, randomly or sporadically. Now, once you have insight into these analytics, you can have another round of tests, probably taking advantage of the counters, or taking advantage of the navigation timing API that Selenium provides, and log those numbers for connect times and do an analysis on what exactly is the connect time for all the requests on your web page throughout a test. If you consistently see that there are deviations in the connect time, that actually points to connection level problems. Now imagine anyone getting into this particular quick identification of bottleneck with a regular JMeter test that's without a monitoring tool, without a monitoring mechanism. It takes a lot of time. It can take a couple of days. It can take 3 days, 4 days, depending on who is available to do that stuff and what data do we have from the JMeter test. But compare that with what we are doing here, you have a visual representation of what's happening with your web browser whenever an SLA is violated. And you put all that stuff together, that provides a complete picture to your CXX or CIO, CEO, your senior managers, everyone else, which is completely different from your regular conventional load test metrics, which only make sense from the server point of view, but not from the end user or a browser perspective. So I'll stop here because that's what we wanted to tell you in order to use Selenium WebDriver using different browsers to get the real user perception of performance, and what are the timings that can Selenium provide in order to play around with those particular values and put those numbers into place and provide data visualization techniques. I'll take any questions from now. If anyone has a question, you can use the mic over here and ask me.
Given that you are using browsers for load testing, how many users you are able to simulate? Can you simulate 100,000?
Okay, the question is, we are using browsers to simulate load, and how many users are we going to emulate per load generator is what is the question, right? It really depends on the application profile. When I say application profile, when you load up this browser on a Selenium WebDriver, depending on what's there on your page, it's going to take a certain amount of memory. And we do this all the time with a normal load test tool. We do a scalability analysis of a particular load generator for a given configuration. And we then take a decision on whether we can put 50 users or whether we can put 100 users on that particular system. But according to me, if you are actually load testing using this particular hybrid approach, using JMeter and browsers, you can put 95% of your load on your JMeter API load testing, that is virtual user load testing, and move 5% to your different browser combinations, and make sure those browsers are actually on different virtual machines than what JMeter is on, in order to make sure that you are not actually affecting both solutions by inducing some bottlenecks at the infrastructure level. And one more thing you can do is, when you do that on different virtual machines, you have access to certain network virtualization tools. For example, we use NetLimiter quite extensively, and you can spin 5 virtual machines with 5 different network configurations, and then that tells you at 56 kbps speed what is the performance of your page going to be versus 1 Mbps. Did I answer your question?
Yeah.
Yeah.
Question?
Yeah.
You may have addressed this at the beginning, I may have missed it, but to drive the WebDriver code from within JMeter, I know there are some extra plugins. There's a project called JMeter Plugins that has some WebDriver components. Is that what you're using, or what specifically are you using to drive the WebDriver?
I'm using Bean Shell Sampler here.
Okay.
Yeah.
Great.
Sorry? Okay, the question is, what is that I use in JMeter to drive the Selenium WebDriver? So the listener I'm using here is a Bean Shell Sampler. Yes, you can. YSlow is, again, YSlow is based on the 12 standard rules that Steve Sauter has set. And YSlow comes with a disclaimer saying that not all rules are applicable to all websites, and it takes your experience and your developer's experience to see whether that particular YSlow recommendation is a valid recommendation or not. For example, I'll give you a real life example that I have come through. There is a similar tool that is a tool similar to YSlow is Google Page Speed Analytics, which used to come inbuilt with the Chrome browser. And when I ran a particular website on Page Speed Analytics and asked it to analyze it, it asked me to put caching in place for certain JSON objects. But then, if I put a caching in place there, I'm going to get stale data on my web browser. So I'll be careful when using YSlow, Dynatrace as addition, Page Speed Analytics, not to disrespect them. They provide a lot of information, but you are the best judge for your application. Your developers are the best judge for your application in order to see whether any recommendation makes sense or not. For example, if you put your web page through YSlow, it tells you move all the JavaScript to the bottom of the page in order to minimize the delays. But what if your JavaScript is doing a DOM manipulation? So what happens is you put that JavaScript to the bottom of the page, everything gets downloaded, everything gets painted, and the moment the JavaScript at the bottom of the page loads up, it does an entire DOM manipulation again, and the page refreshes, which is something that you don't want to have. Did I answer your question? Yep.
Do you find it hard to maintain all those bean shells? I mean, bean shell itself, you have everything in JMX file. So how do you handle it with bean shell?
Well, Bean Shell is just a listener. What you're actually using there is a Selenium WebDriver script. So it's the same effort as it takes to maintain your Selenium WebDriver script. But then the suggestion is to use this Bean Shell driven Selenium WebDriver approach for your business critical transactions and not for every transaction. That's just because it adds to the overhead of maintaining those test assets. So it's reaching that optimal point on what transactions do you want to use this particular Selenium WebDriver for versus the effort that you're going to put it on for the maintenance.
Yeah, that's clear. So, for example, Git or whatever you're using, so all your bean shell code is stored in JMX files?
Sorry, I can't hear that question.
Okay, so you have JMX files. Okay, so all your shell code is inside those JMX files.
Yeah, that's right. Any more questions? There are no questions. You get 5 minutes back. Thank you.